Alright, I'm Gage Carr and this is my Lab 1 video. The purpose of this lab is to become familiar with labs at home, understanding how electric force and gravity act on objects. And we also explore the idea of charge, so whether an object has a positive or negative charge, the amount of charge on an object, and the excess charge on an object. We used Coulomb's law and Newton's second and third laws as our principles throughout the lab. The results, the charge on the tape was 1.49 times 10 to the negative 8 coulombs, and it was positively charged. The amount of excess charge on the tape was 9.3125 times 10 to the 10th electrons, and the ratio of electrons to atoms was 2.45 times 10 to the negative 7th. Expectations going into this lab, I thought they would have the same charge as the lab instructions described one piece of tape floating due to the other piece of tape. Some observations, both tape 1 and 2 attracted to my hand, indicating like charges. Tape 1 and 2 repelled, again indicating like charges. And both tape 1 and 2 attracted to the neutral book, which doesn't tell you much because both positive and negative charges attract to neutral objects. And lastly, tape 1 and 2 attracted to a negatively charged pen, indicating that they're positively charged. Assumptions, the first was that the tapes have the same net charge. Second, I treated the tapes as if they're points, so a single point in the middle of the tape. And thirdly, I didn't consider air resistance as a factor. So firstly, to find the charge on tape, we need to find the force of gravity, which is done by multiplying the mass of the tape times the acceleration of gravity. After you found that, you can move into using Coulomb's law. So you're allowed to assume the charge and the distance are the same for both particles. And after some algebra, you can get that Q equals the square root of the electric force times 4 pi epsilon naught times d squared. And we know that the electric force minus the force of gravity equals 0 as the tape is floating. Therefore, the electric force is equal to the force of gravity, so 0.001962 newtons. Once you plug in all the other values into the given equation above for Q, you get that Q equals 1.49 times 10 to the negative 8th. Moving on, you need to find the number of electrons, which is done by dividing the charge on the tape by the charge of one electron. From there, to find the number of atoms, you find the area of one atom by multiplying the given length of an atom times itself, and then dividing the area of a piece of tape by the area of an atom, giving you 3.8 times 10 to the 17th atoms. And then the ratio of atoms to electrons is straightforward. You just divide the electrons by atoms, giving you 2.45 times 10 to the negative 7th. Moving into coding, so you can see the result above. The blue dot is tape 1, the red dot is tape 2, the white arrow is the force of gravity, and yellow arrow is the electric force. Below is the same results from the previous slides that I just gave. So to dig into the coding a little bit, firstly, you can see the constants up above, pretty straightforward. Moving down here, you can see that each of these print statements outputs the same result as given in the slides that I just showed. And down here is just creating the arrows. The only difference between these two is the force of gravity is positive here, which is really the electric force, so the yellow arrow. And this is times -1 to give the arrow indicating gravity. Back to the presentation. To answer the two questions given in the lab assignment, if electrons had a positive charge and protons had a negative charge, what would happen? It would basically be the same experiment, except some observations would be different. And the reason why you don't want to handle anything is just because you don't want to lose or change the charge. And that's it. Thank you.